So here comes the last topic of this episode number 10, where we are testing the ratio of two population variances. So far we were discussing test the mean of two populations, but now we are dealing with variance. When we test variance, that either the variance of two populations are same or different, in that case we apply F statistics. So point to be noted, this is the thing which you need to remember. When do we apply F statistics? So when we discuss the variance or we test the variance of two different populations, in that case we apply F statistics. Otherwise we apply T statistics when we apply when we test mean of two different populations. So as you know, variance is always positive, so there is no lower tail. So there is always positive, either right side or two tail. So null and alternate hypothesis will take the following form: H naught sigma 1 square equals to sigma 2 square, or its alternative is H1 sigma 1 square not equals to sigma 2 square. So its formula is very simple. We say F equals to S1 square over S2 square. S1 square variance of a sample 1, the larger sample variance, and N1 is sample size. S2 variance of sample 2, the smaller sample variance. So the formula can take the form accordingly. For example, if S1 is the larger sample variance, it would be in the numerator, and S2 is if it is the smaller sample variance, then it would be in the denominator. And its degree of freedom, because we have two populations, so degree of freedom will be N1 minus 1 for the first sample and N2 minus 1 for the second sample. So here you can see its formula: F statistics equals to S1 square over S2 square, and degree of freedom, there would be two degree of freedoms. df1 equals to n1 minus 1 and df2 is n2 minus 1. And as I said earlier, variance is always positive, so there is no lower tail. So we have only right tail, the positive side, or we will have two tail, alpha by 2. The only thing we just divided by 2, we only divide alpha by 2 in case of two tail. We solve the same example, if you can recall, we were in section 5.1 of this chapter. We had solved the same example. The only difference is there a difference in the variance? If you can go back, you can check on your own. The question was in 5.1 section, is there a difference in the mean between the NYSE? Then we will apply t-test. But when we are testing the variance, now we apply f-test. You can compare, both examples are exactly same. The only difference is the word mean and variance. Here everything is same, whole statement is same, the whole situation is same. We are only testing variance, so the formula will be F, and if we test mean, the formula will become t-test. So we are given everything. Here you can see F stat S1 square over S2 square. So S1 square is 1.30 and S2 is 1.16. We can substitute and we can get F stat 1.256. And now the next thing is how to find the T critical, the F critical. As I said, there are two degree of freedoms, like N1 minus 1 and N2 minus 1. The numerator degree of freedom will be on the x-axis and the denominator degree of freedom will be on the y-axis, or so called in the column and in the row. So, and also like for f stat, if we are checking it for alpha 0.05 or alpha 0.025 or alpha 0.01, for every alpha we have different tables. So first of all, you will see that either we are seeing, for example, here we are checking F critical for 0.025. You will see, go back to the back of the book and see where it is 0.025. You will see 0.025. Then here you will see degree of freedom and degree of freedom, where they intersect. There you can find your F critical. So this is how we find F critical, and rest of the things are same. Reject H naught if F stats absolute value is greater than F critical.